Hello, everyone. This is episode 851 of the People Behind the Science podcast, and I'm Dr. Marie McNeely. Thanks for tuning into this episode with our guest, Dr. Kristen Rasmussen. Listeners, research in Kristen's lab focuses on studying extreme events, particularly weather events such as heavy rainfall, thunderstorms, hailstorms, and other events that have a big impact on humans and society. She's interested in examining these extreme event systems in the context of our current climate and how they may change in the future. So I'm excited to revisit this conversation where Kristen shared some of her outstanding insights, stories, and advice. Listeners, I hope you enjoy this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to People Behind the Science. Today, I am delighted to be speaking with our guest scientist, Dr. Kristen Lani Rasmussen. So, Kristen, welcome to our show today. How are you?
I'm doing great. Thank you.
Well, thank you for joining us and sharing some of your stories and your science with us. Before we jump into all the details, let me first take a moment to tell our listeners a little bit about your current position and your background. So, listeners, Kristen is assistant professor in the Department of Atmospheric Science at Colorado State University. She received her bachelor's degree in meteorology and mathematics, as well as music, from the University of Miami. Kristen then attended the University of Washington, where she was awarded her master's and Ph.D. degrees in atmospheric sciences. Afterward, she conducted postdoctoral research at the National Center for Atmospheric Research before joining the faculty at Colorado State University. And Kristen has received a number of awards and honors in her career, including the Peter B. Wagner Memorial Award for Women in Atmospheric Science from the Desert Research Institute, the College of the Environment Outstanding Community Impact Award from the University of Washington, and also the Very Early Career Award from the American Meteorological Society's Mesoscale Processes Conference. And in addition, she was recently awarded the Graduate Mentoring and Advising Award from Colorado State University, as well as the George T. Abell Outstanding Early Career Faculty Award from the College of Engineering there at Colorado State University. And Kristen, we are excited to learn more about your research and you as a scientist, but also you as a person in general. So can you start by telling us what you like to do when you're not very busy doing science?
Sure. I think one of my favorite things is to hang out with my family. I have a 2.5-year-old daughter and another one on the way. I also am a jazz trumpet player, so I like to kind of balance the science with a little bit of creativity and music, the right side of my brain. So I try to play in jazz bands, and I'm playing with some bluegrass bands here in Colorado to keep me balanced.
That is amazing. And I know I mentioned in our introduction that you also majored in music in college. So how did you first get interested in jazz trumpet specifically?
So I played a lot in middle and high school, and I actually went to college originally for music only. I was a music major, had a music scholarship to the University of Miami. And I realized that I wanted to have a little bit more balance, and I really have always loved science. And so I added it on. I took a couple of classes my first semester and realized I really had a passion for science. But I did not remove my music major because I loved going from high-level math classes to salsa band. Mm-hmm. And it was very balancing and kind of kept me level as I weaved through undergrad all the way through graduate school.
I love it. So let's talk about the science next. How do you describe your work, Kristen, to someone who's not very familiar with your specific field or maybe not a scientist?
My specific field is looking at extreme events, especially weather events. We look at heavy rainfall, we look at thunderstorms, we look at hail producing storms, just events that have a lot of impact on human and society. And we're looking at how these systems look in the current climate and also how they may change in the future.
Oh, that is awesome. And as someone myself who grew up watching the Weather Channel for fun, I can't wait to talk about some of these projects during our conversation today. But next, I'd love to talk a little bit about motivation. We talked about how you've got this draw towards music as a balancing force to have the music and the science going simultaneously. Are there other things that you find really motivate you or help balance you in life, maybe quotes or sayings or forces?
So growing up, my parents really instilled in my sister and I a very hard work ethic. That was something that was very apparent throughout our childhood. And I have applied that actually both to my jazz and my science careers. I'm really driven by the 10,000 hour idea from Malcolm Gladwell, where when you work on something for 10,000 hours, you become an expert in whatever that is. And I found that very apparent with my music. I reached the 10,000 hour mark while I was in the middle of grad school. And I had this transformation in my improvisation where suddenly I wasn't telling my fingers what to do, and it was actually doing it by itself. And I was creating better solos than I could have if my brain was directing my fingers. Graduate school is about that same amount of time. 6 years is about 10,000 hours. And I tell that to my graduate students, and that has motivated me to become an expert in many different topics.
I love it. Well, Kristen, great to hear a little bit more about what motivates you. And I'd really like to talk next about some of the people who might have motivated you. You mentioned your parents had this motivational force kind of instilling this work ethic in you from an early age. Are there others who really helped you along the course of your career who you really looked up to?
So it's funny you mentioned that. My father is actually also a meteorologist. So I'll mention a couple people in addition, but watching my father completely in love with his career, he had fun every day. He would go to work and come home and would be excited. Watching that for me as a kid, I think helped me realize that the science career might be something that I'm interested in as well. I've also had a lot of really fantastic educators and teachers along the way. I had a third grade teacher who was just amazing and I think changed the course of how I write and think. So I'm really grateful to all the teachers that I've had and all the educators that have helped me along the way. And that's one of the reasons I actually wanted to become an educator myself.
That is amazing. So did you ever reach out back to that third grade teacher and tell them what impact they had?
I have actually. Yeah, I went back and saw him a couple of years ago, and he's always thrilled to see students that have successfully gone on and taken the skills that they have instilled in us, even from a very young age. And he was very happy to see me, and it was a really special moment.
And you mentioned that your father was a meteorologist as well. So you might have been talking about weather and climate around the dinner table, perhaps. Do you remember some of these earliest moments when you first started getting interested in or excited about science?
Absolutely. My dad studies winter weather and snow. So I grew up as a kid jumping in the car with him every time there was a blizzard here in Colorado, going out to his field test site and collecting snow data. So I thought that was a normal childhood. I thought that was what everybody did, but realized that it was actually not very common. But I think I instilled that early curiosity and doing even field work from a very, very young age. So I think that definitely helped me. And I'm trying to do that with my daughter. We brought her down to Argentina for a big field campaign that I'll talk about later. So I think it's important to get kids started early and keep that curiosity alive.
Absolutely. And I understand you've got some winter weather going on there now in Colorado. So is it fun to get outside and explore it and enjoy it firsthand?
Absolutely. We had about 18 inches of snow at my house just overnight, and it's been pretty exciting. My daughter was up to her waist in snow.
Oh, my goodness.
Got started early.
That's right. I love it. And we talked about kind of your earliest days getting excited about science, but where did you go from there? You mentioned you had some great influential teachers along the way. What are some of these key moments that really helped you get from that point of being a kid excited about science to where you are today on the faculty at a university?
While I was an undergraduate, I had the opportunity to participate in a large field campaign. This was a field campaign studying clouds in the Caribbean. And I was invited to go on this journey as a research experience for undergraduates program. This is a typical program funded usually by the NSF that brings in undergraduate students to kind of do field work or research to get extra experience before you think about going to grad school. So I was put on a boat in the middle of the Caribbean, and I was launching balloons in the middle of the night. And I realized in that moment that I really loved being out in the field. I really loved looking at the clouds, launching instruments into the clouds and observing them and learning something about them. And that experience was really what propelled me to apply to grad school and has kept me going. I still do field work to this day.
That is amazing. And then can you talk about these steps? You mentioned you went to undergrad. You had some great experiences there. How did you decide what direction to go for graduate school?
Well, once I had the field experience and I realized that this is something I was passionate about and I really liked it, I applied to a couple graduate schools, but I really was focused on the advisor. I knew that it was a really important thing to find a good match with an advisor that was doing a project that really was interesting to me, but also personally I connected with. So I asked a lot of my mentors at the time and asked for which schools and the advisors I should be applying for. And that led me to the University of Washington. I worked with a very well-known but very caring advisor named Robert Howes Jr. at the University of Washington. And he brought me on a couple of field campaigns and had a great experience at the University of Washington with him.
Definitely. And then you came back a little bit closer to home for your postdoctoral experience. Can you talk about what it was like doing research there at the National Center for Atmospheric Research as a postdoc?
NCAR, for short, is a think tank in our field. So there's lots of scientists there. There's tons of visitors that come through. It's a really valuable resource, and it was amazing to work there. I got to see so many people from the field coming in. I got to talk to a lot of really high-level scientists about things that I didn't know much about, that I didn't learn about in graduate school. I also tried to do a project that was very different from what I did in my graduate work. So I was trying to branch out a little bit to provide a little bit more basis for when I eventually had my career. So it was a great experience, and it's a major resource in our field, and it's really fantastic to be just an hour north of NCAR.
Definitely. And I know many of our listeners out there are graduate students or postdocs contemplating that next stage of their career. What was going through your mind when you were making that decision for yourself, whether to apply for faculty positions or what direction to take next?
Yeah, it's something that postdocs and grad students constantly think about. I was not the type of person that always had a faculty job in mind. I have some friends that have basically always wanted to be faculty at a university somewhere. And for me, I remember this experience when I was at NCAR as a postdoc. I was in a fellowship program, and we were in a room with about 20 postdocs. And the director of the National Science Foundation, France Cordova, came in. She wanted to come talk to the postdocs specifically, and she asked us how we felt about future jobs and funding and careers, and we all were basically really stressed out about it. She told us a really inspiring story of her journey, where when she was at our position, a faculty job wasn't available, and she basically looked at the options that were in front of her and took the best opportunity. So that led her to the Los Alamos National Lab, and then that led to other things. She became the chair of a department, and now she's the head of NSF. And so she said, don't stress out about this one step. Take the best opportunity that's provided to you at the time, and then you never know where that will lead. So I think all of us kind of breathed a sigh of relief, and that was really refreshing for us to hear at that stage. And I think that's the advice that I now give my postdocs and my grad students, that the perfect job for you may not be available at the right exact time, but you never know where a really good opportunity will lead in the future.
Absolutely. And I think just taking a next step, regardless of what that might be, I think is helpful, even if people feel like their career is uncertain in terms of what direction it's going to ultimately end up in.
That's right. And you never know what doors or what opportunities lie ahead. So try not to be too stressed out and think about the best opportunity moving forward that will open many doors as you go forward.
Definitely. And enjoy the journey, right?
That's right.
So you've got so many great projects going on now there at Colorado State University. So can you tell us about one of the projects that you are just the most excited to be working on?
So I did my Ph.D. research on intense convective thunderstorms, some of the biggest and most intense thunderstorms in the world. And they happen in the middle of Argentina in South America. So before I started my research, we didn't really know that these storms were among the biggest storms in the world. And a spaceborne radar, precipitation radar that's actually looking at the three-dimensional characteristics of the storms, told us that these storms are among the most intense anywhere in the world, and nobody knew why. So I spent my entire PhD looking at these storms, trying to understand them. And we just did a large major field campaign called Relámpago in fall of 2018, where we brought a suite of radars and weather balloons and a lot of detailed instruments down to Argentina to study these particular storms to try to get a better idea. And so this is probably my main project, and it's one that I'm really excited about because it's a kind of an unknown place in the world. And we're working in close collaboration with the Argentinians and the weather service there to help not only understand the storms there, but also provide information for forecasting and warnings and things like that for the population.
Absolutely. And to give our listeners some context, I understand that these severe storms in that area generate golf ball size to grapefruit size hail, which I can only sort of wrap my mind around. So what is it like to be there during these storms?
It's pretty intense. They have some of the highest frequency of very large hail in the world, and the hail happens right up against the mountains. So there's a city called Mendoza, and they have a very large wine production. I think it's 30% of the exports of Argentina are wine, and Mendoza is one of the hotspots for wine production. And they also get orange and grapefruit size hail on a regular basis every year. So you can imagine this is a huge societal impact, and we don't quite understand why they get such large hail close to the mountains. I live here in Fort Collins, Colorado, and we don't get grapefruit size hail on a regular basis. It's actually incredibly rare to get even golf ball or larger right up against the mountains. We look much farther to the east to see large hail. So to be in the presence of these extremely large hailstorms, it's just pretty amazing. We did experience a couple while we were down there in the field, and they're pretty intense.
Definitely. So can you talk about, I guess, some of the measures that your group takes, or maybe what your field site looks like in terms of how you can take shelter? These hailstorms happen pretty quickly, it sounds like.
Yes. So we brought down a bunch of different instruments. One of them is a bunch of trucks that have radars on them. So there's a cab inside where people can go in. They're safe inside. We do have students launching balloons. They launch them out of trucks in their mobile soundings. They're scattered around the region. If it's too dangerous for them to launch, we just have them stay in the vehicle, of course, because safety is more important than launching that weather balloon. So we try to keep our staff safe. We have people watching in real time any of the hazards that are nearby, especially things like tornadoes and large hail, and communicating to the students out in the field in real time. So we try to make sure that we're as safe as possible, but sometimes it's hard to anticipate everything that will happen.
Absolutely. And what are some of the next steps in terms of learning more about why these storms are so severe under these particular conditions?
We've received most of the field data back. We're now in the fun process of processing and analyzing the data that we collected. In the field, you're just basically trying to make sure that you collect all the data that you want or that you will need to do the analysis. Now, all the scientists and the students are digging into the data, looking at the details, processing the data in specialized ways to look at the intensity and the characteristics of the particles in the storms and things like that. So the real work begins now, and we'll be looking at this data set probably for 5 to 10 years.
Oh, wow. That's exciting.
Yeah.
So are there any hints so far? Do you have any hypotheses going into this of what you might see?
The primary reason that these systems are some of the biggest and most intense in the world is because of the presence of the Andes Mountains. The Andes, just to give our U.S. listeners a little bit of context, are about double the average height of the Rocky Mountains. So they're very, very tall. They're a pretty narrow barrier. And because of that, they actually deflect a lot of atmospheric flows on both the west and the east side. So it's that presence of the mountains that actually has a big role in the intensity of the storms. So what we're looking at now is the interaction between the actual convective systems that are developing and the topography and the foothills of the Andes on the east side. Those are some of the specific questions we're looking at. We also have very rapid growth into very large systems in this region that we can't quite explain from what we know about in the United States. So those are some of the specific things that my group is looking at right now.
Certainly. And in this discussion, we touched briefly on some of the challenges that you encounter just in the field work that you do. But I love talking about these challenges because I think it is so important to give our listeners out there a realistic sort of behind the scenes view of some of the struggles, the failures, the difficult times that scientists face in their work. So, Kristen, do you have a favorite story of a failure or challenge that you can tell us about today?
Yes, I do. I tell this to my grad students actually when they enter graduate school. And I'll just note from our previous discussion that fieldwork is full of failures and successes, both sometimes right next to each other. And so I think that that's just part of science. But my favorite story of a failure in my first year of graduate school, one thing that I always have thought about is that it's hard to transition from an undergraduate or a K through 12 through undergraduate frame of mind into the graduate student frame of mind. The reason is because when you're an undergraduate and all the way through kindergarten, you're given a problem set. And there's an answer to that problem set, and you're supposed to produce that answer. The challenge is when you get to graduate school, you kind of flip that on the side and you say, okay, well, we have a question. We don't know what the answer is. We don't know if we will ever answer this question. And you have to make progress toward that answer somehow in your graduate career. So when I came in from undergraduate into graduate school, I remember thinking to myself, what analysis should I do on my research project that will answer the question my advisor has asked me? Mm-hmm. In other words, I was trying to find the answer to the problem set for our research question, but it turns out he didn't actually know the answer. He was waiting for me to take the most important path through the research to find something new. So I remember going to him and bringing him a couple of figures, and he would tell me, well, what's the point of this? What question are you answering? And I didn't really have an answer for that. And so I went back to my desk and I said, okay, I think I'm thinking about this wrong. And it was at that moment that I made the flip where I realized that doing research, we're at the cutting edge of human understanding. We don't know the answers that we're trying to get. So pushing forward into original and new ideas is actually very challenging to do. And it by nature comes with a lot of failure, but it also can come with some really extremely exciting discoveries. And that's the way that science has been revealed to me throughout my research career. So that was an example of a failure that I turned around and have changed my mindset to figure out how to do research in an effective way.
That's wonderful. And I'm really glad you brought up this story because I think this is something that you're absolutely right. A lot of graduate students struggle with because it is a shift in how you think. I think so often as students, you're used to your teachers and mentors and advisors just always knowing the answer. And you're right. It's up to you to get to their answer. But that moment where I realized my advisor didn't know the answer was like a huge eureka moment for me or aha moment.
Absolutely. So I try to tell my students this story when they come in, just so that they have this in their mind as they're going through, that we're looking at research questions that maybe nobody knows the answer to, or maybe we won't ever find it, but we can pick away at the pieces to get us something close to the answer. So I think when graduate students kind of get bogged down or frustrated when there's a lot of failure, it probably means that they're looking for the right things. They're just not quite at the breakthrough level yet. So just keep trying, keep that perseverance up.
Definitely. I think that time scale is something that you don't necessarily appreciate as a graduate student too. Like you said, the data you collected in your fieldwork will keep your lab busy for 5 to 10 years. And I think we're so used to immediate answers going through our school years that when you get to this point where it's going to be years before you know the answer, that's a big shift too.
Absolutely.
Well, we touched on some of the challenges, Kristen, but I'd love to talk about some of the successes as well. So do you have a favorite success story or two you'd like to share with us today?
Sure. I'll tell a couple things. The first one is when I was a postdoc at NCAR, I decided to shift my focus of my research to do something a little bit different, using the skills that I had gained from graduate school, but applying them to a different topic. And so I actually started looking at some very high resolution regional climate models and looked at how the convective storm population, so basically storms that are very weak all the way through very strong, may change in a future climate. I had done no work on the climate change aspect during graduate school, but I wanted to apply the knowledge that I had of cloud dynamics to the field of climate change. So we wrote a paper basically on these interactions of these very kind of the whole spectrum of convection from weak all the way through strong and how they may change in a future climate. And that paper has actually been really important and it's basically gotten a lot of attention. And it was kind of just like my side project that I was moving to broaden my career and my research topics. And it's actually formed a whole new line of research in my group. So I'm really happy that I had that opportunity and happy that it's led to so many good things down the line.
Absolutely. Well, congratulations on this. And I think it goes along with what you said previously. You never know what opportunities will come up or what doors will open for you.
That's right. The other short story I can share with you is related to the fieldwork. So again, I told there's a lot of failure with fieldwork. You try to get a sounding in the right place and the storm moves or something like that. We had a goal of observing a very large upscale growing convective system, so a very large mesoscale convective system during the campaign. And up until basically the last couple of days of the campaign, we had not observed something like that. And that was part of our primary objectives for my group. So on the second to last day of the campaign, this large system was starting in the region, and we placed our assets perfectly to capture exactly what we wanted to see. We were all a little bit nervous because it was right at the end of the campaign, but we did capture the system that we wanted to with the observations that we placed correctly. So that was a huge success for our research group and our research team.
Well, that is phenomenal. And I think you hinted at just the stress of field work, not only making sure the experiments go smoothly and things happen, but you're depending on the weather here in your case. So what is it like being under that pressure of you only have X number of days left before you have to leave and you may or may not have the data you want?
It's a lot of pressure and Mother Nature does what it wants and we have to go along with it. And so sometimes we modify our science objectives based on what we're actually seeing in the field. In this case, we did get lucky and we did see the exact type of system that we wanted to before the end of the campaign. But when you go out in the field, just like when you're trying to observe anything in Mother Nature, you have to basically come with what's there. And these field campaigns are short. We had about 2 months of time and you're not going to see everything you wanted to see, but you have contingencies and you have plans in case you don't see exactly what you're looking for.
Certainly. So do you think once you make it through, you mentioned 5 to 10 years worth of data analysis and processing and things like that, is there another trip in store for you to this area?
We hope so. Yeah, a lot of times what we do is we'll learn something about the region and based on remaining questions or things like that, we would sometimes propose a new campaign to go to the same place to test new hypotheses or refine what we learned from the previous one. That's fairly common to do. But on my schedule, we have another campaign that just got funded recently where we're going to Taiwan next summer to study heavy rainfall. So these projects kind of jump around the world. We go all over the place to study interesting science questions, but we hope to someday get back to Argentina.
Oh, very cool. Well, Kristen, it's been great to hear about your research. And I know as a scientist, you're constantly immersed in the literature and trying to stay up to date on everything that's happening in the field. And it can be hard to fit in time to read for fun, but I'm trying to do more of it in my own life and encouraging our listeners to do so as well. So do you have a favorite book, whether it's related to science or not, that you can recommend for us to add to our reading list today?
Yes, I actually have 2. They're not related to science. I actually like a lot of science fiction books, but I won't go into those. Probably pretty standard from what everybody else likes to. There are 2 books that I really think are important, especially for kind of a grad student postdoc listener. The first one is if you're considering to be in an academic career, there's a book called The Professor is In. It's fantastic. It's written by a woman who was previously a professor and now runs a consulting business to help graduate and postdocs look for jobs and apply for jobs and interview for jobs. So it's a really fantastic reference that I used very, very much in my process. The second book that I would like to recommend is called Mindset. It's by a psychologist. She's a professor at Stanford. Her name is Carol Dweck. She has this idea that it's called the growth mindset, where skills and things like that can be learned over time. So you can basically, through hard work and through perseverance, you can improve your skills, you can be more successful, and you can basically achieve the goals that you want. For example, they did a bunch of surveys across a wide spectrum of the society, including West Point graduates and Fortune 500 company members and all kinds of people across society. and they looked for statistically significant metrics of personality that could be traced to success. And the only characteristic across all of those groups was what they call grit or perseverance or hard work. So it tells you that even if you come from a disadvantaged background, if you don't have the right skills that you think you should, if you don't have the right training as somebody else, if you work hard and you have that perseverance over time, that's the most likely characteristic to make you successful. So I think for me and for my graduate students and for the people I talk to, this book has really changed the way I think about not only life, but also about how you can be successful in general.
Wonderful. Well, these are 2 new books that no one has recommended thus far, so I'm excited to add them to our website for our listeners to find there. And we touched on some of the great travel opportunities you've had for your career and also this upcoming trip to Taiwan. And I love talking about travel with scientists because I think you have so many great opportunities to see different parts of the world, to meet with scientists, to go to conferences, and to do field work in your case. So do you have a particular favorite place that your science has taken you?
I would say it's probably Argentina with the field campaign that I have previously discussed. The reason is I studied these storms from afar for about 10 years before we actually went down to the field using satellite observations. So trying to understand these systems from space. And when we went down there, we were working with the Argentinian Weather Service. We were working with locals to put sites in places. So it was really exciting not only to be in the field, to see the storms that I've been studying for 10 years using remote observations, but also to interface with the people who experience these storms, to talk to K through 12 students and do outreach events about the weather that we're learning about and to teach them about things. I think it's really that connection to the community and the locals that made that particular trip so memorable and so special, but also scientifically, just being able to see the systems that I've been studying and trying to understand was really exciting. I think a lot of the field campaigns we do try to connect with the locals and the community, and that makes these experiences so special.
Well, it sounds like an amazing experience, 10 years in the making, like you said. So what was it like, the first storm you saw while you were down there, actually seeing it in person?
It's hard to describe it. I kind of felt like a giddy child, just so excited because I've seen these systems from satellites and from all different types of remote observations, but just seeing a storm in person was extremely exciting. A bunch of us were kind of up on the roof taking pictures and getting really excited about it. It's amazing when what you can see with your eye. A lot of the intuition actually is important, and we also like to make sure we have that intuition when we go into the research. But it was incredibly exciting, and I was grateful for the opportunity to actually see these storms in person.
Definitely. And you touched on your opportunities to do outreach and to talk to some of the local people in the community. Can you go into a little bit more detail about what it was like getting in there, maybe in the classroom or working with some of the kids there?
It was fantastic. We had a great partner in Argentina. He's a professor there, and he actually runs some really fantastic K through 12 activities. He goes to different schools and purchases weather stations for them, and they read off the values and submit them to his website, and so they can kind of get involved in the science observations. We did a really large event, about 500 students actually, in one of the cities right nearby where we were, near Cordoba, Argentina. And we went in and we were talking to the students about their experiences with the weather. And we asked all these students to hold up with their hands the type of hail that they see. Mm-hmm. And they all held their hands up, and they had huge circles in their hands showing these orange-sized or larger hailstones. And to us, this was really shocking because those types of hail, they don't usually happen that often in the U.S. We get a lot of big hail, but that was just the type of hail that they see all the time. So for them, it was just normal. And for us, we were like, wow, they are all seeing this really large hail. This is really amazing. So to be in a community that experiences such severe weather, and it's just a part of life, they were actually really surprised to learn that their weather is some of the most intense anywhere in the world. They didn't actually know that. And so that was really an interesting type of interaction we had with them. They also asked us a lot of questions about what it's like to be a scientist. And they saw that we had actually a really nice, diverse group of people in front. We had a lot of women. We had a lot of ethnic minorities as well as part of our research team. And I think that was really good for them to see that scientists can look very different. So that was another thing that we liked about some of those events.
Definitely. Well, that is phenomenal, Kristen. And I know that mentoring and teaching are big parts of your job right now. So can you talk a little bit about what that's like for you, being able to pass on this knowledge to the next generation of scientists?
It's one of the best parts of my job, I think. I love teaching students. I love working with my own grad students, and I love working with K through 12 students as well. I think all of us have that moment when we were little where we had that spark of interest in something. For me, it was not only the movie Twister, which many meteorologists that are similar to my age will tell you kind of motivated some of us to go into the careers. I actually saw a tornado when I was in 6th grade. And I always remember that experience and just that spark of curiosity back when I was a little kid. So I like to make sure that if there are kids who are interested in science that can be encouraged to stay in science, it happens at a young age. Middle school is a really critical time. So reaching out to the middle school kids and then continuing the support all the way up through graduate school is something that I really like to do. And it's something that I am passionate about.
Absolutely. And I'm so happy to hear that you are getting out there in the community and introducing people to scientists who may not otherwise have an opportunity to meet someone who does science for a career. I think that's so important. And I think it's key also to try and break some of the stereotypes that people have about what scientists are like, what they look like, what their jobs are like, and what life as a scientist is like, because how the media portrays us is not always how it looks in reality. So I love talking to people on the show about just some of the great experiences they've had with colleagues, some of the funny traditions that happen, and just this human side of science. So do you have another story along these lines that you could share with us today, Kristen?
Sure. So as I mentioned at the very beginning, I was a double major with music. So I've always been a musician. And when I was at the University of Miami, I had the impression that being a scientist and a musician was a rare combination because it was actually a challenge for me to get my 2 degrees to line up. As I've moved up through the field, I've realized that many very high-level scientists are very good musicians. So at both the University of Washington and at Colorado State University, we have this great tradition of having a lot of music. In fact, when we were at the University of Washington, we had to cut songs out of our holiday program for our holiday party because we didn't want to go over an hour. There's so many musicians and so many people that wanted to get in a song we rewrite the lyrics to that have weather themes or things like that, that we would have to cut back because there's so much interest and so many fantastic musicians available in the department. So I think that's been one of the most exciting and unexpected things that I've seen with scientists is that a lot of us are also creative people and we express that creativity in different ways. And a lot of the ways that we do that is through music. I think on our faculty, at least a third or a half of our faculty play an instrument or sing or something like that to a very high level, which is very exciting. So that's been a surprise, but it's led to some funny moments over the years.
Oh, that's so cool. So are there other scientists in the music group that you play in now?
Yeah, there's actually a music group that plays at our fall social every year, and it's all scientists and they play around town. Right now, because I'm in the middle of having a toddler and then a new baby, I'm not playing in a band regularly, but a lot of the groups that I played with over the years have scientists in them, and it's pretty exciting. I've had an idea of trying to start a faculty band at my university in my department because we have enough musicians to do so. So maybe when I get less busy with my kids at home, I'll work on that.
That sounds amazing. I would totally listen. I think you're absolutely right. Scientists are these dynamic people who are multifaceted. And I've talked to actually quite a few scientists myself who are fantastic musicians. So I think you're absolutely right here. And in addition to the music and the creativity, you are just answering amazing questions in the research in the lab. And I think oftentimes there are challenges that we discussed or barriers, things like limited funding or staff or technology or just how long things take in time that can limit the questions you're able to answer. So Kristen, if we took away all of the normal barriers that you face and gave you any resources you could dream of, what is the one question you would most want to answer?
I was thinking about this, and it's actually a really hard thing because as a scientist, I have about 1 million questions that I'd like to answer. I think the thing that really limits our understanding of what we know about the atmosphere is really the length of time that we can conduct field work. So field projects are very expensive. They take a long time, and they're very expensive to do, particularly in international locations. What I would love to do is take a whole suite of instruments and go to a remote place, whether it's Argentina or Taiwan or the Himalayas, and put instruments there for a very long period of time so we can look at the full climatology and distribution of convective systems using the field observations that we normally only get 1 or 2 months to do. This would help us understand more about the nature of convection across the world, how we can look at these types of systems in models, and how we can then project into the future.
Very cool. So is there a particular place, if you had all these resources and you could just drop the instruments there, where would you want to look first?
I've always been actually fascinated with the Congo rainforest in Africa. It's a place that's very hard to go to. It's politically very challenging, but it's a tropical rainforest that has also very deep convection, lots of lightning, and some characteristics that we don't quite understand fully. And nobody's been able to really go there and conduct fieldwork there. As you can tell, I have kind of a very global view of convection, and I like to think about how convection varies across the globe and how we can make connections to different places. And understanding the convective systems in the Congo basin would go a pretty far way in answering how convection varies across tropical regions, particularly one that has really intense convection right on the equator.
Very interesting. Well, Kristen, thank you for dreaming big with us in your response to this question. And We've talked about a lot of aspects of your research and your career, and I think for a lot of our listeners out there, advice can help them when they're in a tough spot in their own careers. So I love getting advice from everyone we have on our show that we can pass on to them. So when you look back on your own experiences, was there a particular piece of advice that you received that really had a big impact and helped you that you can pass on to us?
There's a couple things I can talk about. The first one is the advice that we got from Dr. France Cordova, the director of NSF, where she said, take the best opportunity that's provided to you, and you never know what doors will open. I also will say that in terms of advice and kind of navigating through careers, make sure that you look for people that have your best interests in mind. So when I was at the end of my graduate career at the University of Washington, I'd finished about 6 years of graduate work there, and I was ready to leave. But my advisor at the time said, we had a couple papers left. And he said, if we take 6 months more for my degree and get those papers all published, by the time you apply for your jobs, those papers will be in print and you can put them on your CV. And at the time I was like, well, everybody's telling me to leave. I don't want to stay in grad school too long. But I decided to take his advice and stay an extra 6 months and take that time to really publish and get all my papers in order so that I could publish for my Ph.D. And that ended up being really important applying for faculty jobs because having those papers in print allowed me to put those on my CV. They were on my record. And I think that really helped me get the positions that I was looking for. So sometimes it's good to kind of think through these things. It's not the best advice for everybody, but make sure it's from somebody you trust that has your best interests in your career at heart.
Definitely. And I think that's a good point that you made there, because I know a lot of people who struggled where they sort of were bringing their PhD work to try and finish up while they were starting a postdoc. And that can make it even more stressful when you're making that transition. So
absolutely. And it's very common still. Like I was still finishing up one paper during my postdoc, but to have had most of them out the door before that, I think it was really, really helpful because 2 years of a postdoc goes by very fast. And a lot of times, unfortunately, in our field, publications are the way that they look for faculty jobs in particular. So getting those papers out is important.
Definitely. Well, great advice for our listeners. Kristen, is there any other last piece of advice you'd like to leave us with, or a last note of inspiration you want to end our conversation on today?
I just like to mention that being a scientist is really exciting. We can study things that we never thought we could do. We can kind of dream up these really cool interdisciplinary projects. I'm working with some snow hydrologists now. I'm learning about all kinds of interdisciplinary science through just Colorado State and other places. And I think that you can make the career what you want. There's a lot of different ways to go forward from private, government, and academic sectors. But it's a really rewarding and exciting career full of ups and downs. And I just like to encourage everybody to continue and build that perseverance and keep the work ethic up. And eventually you'll be successful.
I love it. Well, Kristen, fantastic note to end our conversation on today. If our listeners are intrigued by your research and they want to learn more, can you tell them what is the best way to get in touch or to learn more?
Probably the best way to get in touch with me is through email. My email address is Kristen R, KRISTENR @rams.colostate.edu. I also have a social media presence that I am trying to be more active on. I'm on Twitter. My handle is KRasmusWeather, so KRASMUSWX. And I try to post interesting things that we're doing in the lab, papers from our group, and other weather-related topics of interest.
Sounds lovely. Well, listeners, definitely follow Kristen on Twitter. Get in touch via email if you have any questions. And Kristen, it was such a pleasure to chat with you on the show today.
Thank you very much for having me.
Well, it was great to have you here. We appreciate you sharing your stories and your insights. And listeners, wonderful to have you here as well. We'll see you next time on another episode of People Behind the Science.